hope that people like Chari can come and help you out. Okay. One thing that comes to me, I've been working for long years. We're talking about design of the product and process. Well, I would like to take one very common universal example. Today the world population we talk is about close to 8 billion people, okay, roughly. And if I take that, at least I'm sure minimum 50% of the entire world population uses toothbrush, yes? And on an average, at least 2 toothbrushes per year we use. Okay, now coming to the toothbrush, what we actually do, you take up a toothbrush, brushing back, okay? After the bristles outlive their life, all you do is just throw the toothbrush, pick up a new toothbrush and start using it again. But a person like me looks at from the totally different. See, while making a toothbrush, you are spending money. You are spending money for the amount of plastic that is going into the handle. You are spending money for making the bristles that are going into the toothbrush. Okay, everywhere money is involved. You are spending energy in processing those products. So energy cost comes there. You are using certain machine for molding those things. So machine cost comes there. All this put together becomes your cost. Higher your cost, naturally it becomes more difficult for you to push your product into the market because they are competitive. And what the user wants is a better product at a lower cost. Always, it is universal again. Okay. Now the challenge is, how do I bring down my cost? So I start analyzing from, like earlier, on another occasion I was talking about the ceiling fan. Now here I will come to, what is the purpose of brushing teeth? If we fundamentally ask, why do we brush teeth? Okay. And before that, let me also say, with 8 billion population, with 50% of people using toothbrush, 2 toothbrushes minimum per year, we are talking about generation of about 8 billion pieces of plastic being discarded worldwide every year. And then we talk about plastic pollution. Okay, 8 billion is not a small number. Okay? It could be more. Now, coming to fundamental questions we ask, why do I brush my teeth? Okay? I'm sure not many of you might have asked this question. So it is primarily to remove the plaque and the deposits on your teeth. Okay? They are in different forms. They are basically chemicals. And any chemical, I know, it gets dissolved in any other chemical. So what I am using while using a toothbrush is a mechanical process of removing that deposit. You are just brushing it with the bristles which have an erosion effect. Okay, so they keep cleaning it, keep removing the deposits on the teeth. But tomorrow, supposing there is a chemical engineer coming up with it, he says, hey guys, why are you using toothbrush? Simple, you want to remove the plaque, okay, the deposit on your teeth. Here is a chemical solution I am giving. You just put it in your mouth, maybe a tablespoon or teaspoonful. Just gargle them or run it around your mouth, and that will dissolve all these unwanted deposits on your teeth. And just spit it up and wash your face. It has done the same thing what the toothbrush was doing. Once this kind of a solution comes, so the entire toothbrush industry might go out. Okay. Now, limiting ourselves to the toothbrush for some time to come. If I say, what actually wears out in the process of a toothbrush is the bristles. And nothing ever happens to the handle. But that is what we throw, and where, most of my cost of manufacturing goes into the handle that I am discarding. So my question is always, why throw something that has not worn out? So we come up with a split design, where you have only the wearable part of the product which can be replaced, and the part that is neither wearing out nor getting destroyed in the process is used again and again and again back. And this concept way back in 1985 onwards I was using, sometime in 91, it was also video recorded, different models I produced. And I'm very happy to say that today many MNCs in the business of toothbrush, they have adopted the design as late as in 2021. Okay, it might have taken 30-35 long years for these companies to replicate the design, but we are happy that now we are talking about a design that will go on reducing the plastic waste that is otherwise becoming a problem area. Now, the moment you adopt this kind of a design, your cost of production is coming down. Okay, so a toothbrush that you might be, like selling at 20 rupees today and people are buying, supposing tomorrow the same toothbrush with a replaceable bristle design, you charge another 3-4 rupees for the additional bristles. Okay, and then the handle I can make, something like a tailor-made or a designer handle, which I'll feel very happy to retain that. Maybe you get it in gold, I don't mind. Okay, and have only keep using the wearable part as attachments. So instead of a 20 rupees toothbrush one time use, okay, now I'm giving you 3 rupees additional pieces, say 4 pieces, 1 plus 4. So what I'm adding is 12 rupees more. So 20 plus 12, 32. In 32 rupees, you are offering them 5 toothbrushes equivalent. Just imagine. And if this design comes, naturally people will have a tendency to go for that because it saves them money and also the satisfaction that they are contributing to the environmental control. So that's a accidental social responsibility that is being met. Now this is a very simple example, but when you go to the industry side, it turns out in the industry, my personal experience is all the processes that we have been adopting, although a lot of modernization has come, technology developments have come, but the processes are very standardized. And most of the time, my observation has been, 5 decades is not a small amount. People have not developed the tendency of asking questions, the whys, always. Okay? And here, I would like to take you something like, let us talk about steel industry. Okay? Now, large steel plants, they make different kinds of steels. And one of the hardening steels they make where they use ferromanganese. And one of the very, very large steel companies of India, I won't name it at this stage, they use ferromanganese as an additive. And the concern was that, my consumption norm is very high, 22 kilograms per ton of steel. It costs me a lot and can be reduced. And then they compared their standards along with the private steel plant, which was using the same process. And they were getting their steel at 18 kilograms per ton consumption, 22 to 18. Okay, so 4 over 18 is almost like 12, 13, 14% of reduction in their cost of operation. So when you start challenging the same question I asked in the toothbrush, as why are you adding ferromanganese in the first place? Stop it. Don't use it. So you say all 22. Okay. Then suddenly the reactions come, no sir, if we don't add ferromanganese, this will happen, this is what will happen, this is what will happen. And then you say, okay, then you must answer me that how much exactly you need. And like these challenging rounds and questioning, they led us, and we were able to produce, and I was instrumental in that, to bring down the consumption level from 22 kilograms to 9.8 kilograms per ton of steel. Just imagine the wide gap that's available. If only we are mentally prepared to challenge ourselves, our processes, start asking basic questions, and then keep our mind open to think about alternatives to do that, how we can do that. And results are always fantastic. We are never talking about 3%, 4%, 5% improvement, but we are talking about, leap jumps, like 50%, 60% kind. And that is what is required by the industry at large. And there are a series of them. Okay, and I'll revert back to you